In the highly stratified world of aerospace defense, true game changers are exceedingly rare. Most advancements represent iterative progress. A stealthier coating, a faster missile, a more intelligent radar. The Russian Federation's Mikoyan PAK-DP, widely designated as the MiG-41, is not one of these. It represents a doctrinal and technological proposition so audacious
that it exists in a conceptual space between a sixth-generation defining weapon
and a potent piece of strategic disinformation.
Envisioned as the successor to the legendary MiG-31 Foxhound, the MiG-41 is not merely an aircraft.
It is a proposed solution to a new, terrifying three-front war. The battle against hypersonic speed.
The contest for the strategic domain of near space.
And the persistent challenge of defending the largest territorial airspace on Earth.
This analysis will deconstruct the MiG-41 program across 6 distinct, in-depth sections.
We will move beyond the sensationalist headlines of Mach 4.3 speeds and plasma stealth shields
to examine the foundational pillars of the project.
Section 1 will investigate the core strategic imperatives driving Russia's multi-billion ruble investment in a high-speed interceptor, particularly in the context of a new Cold War.
And the lessons from its contentious special military operation in Ukraine.
Section 2 will dissect the profound physics-based challenges of its extremophile airframe.
Exploring the material science required to survive sustained flight.
For it at the blistering edge of the atmosphere.
Section 3 will analyze the propulsion paradox at the aircraft's heart.
The quest for a viable combined cycle engine.
On the argument,
Which that's the meeting.
no, we could just say no. The on meter this thing.
To bridge the gap between a jet and a rocket.
Section 4 will probe its unseen capabilities, critically evaluating the feasibility of its sensor suite
and the realities behind its plasma stealth claims. Section 5 will explore its ethereal arsenal, from advanced hypersonic missiles
To its role as a direct ascent anti-satellite ASAT platform.
Finally, Section 6 will provide a sober and necessary assessment
Weighing the MiG-41's potential as a geopolitical game changer.
against the immense financial, industrial, and technological hurdles
that may relegate it to the status of a technological mirage.
The development of the Mikoyan PAK-DP is not a project born of technological curiosity.
Know that it is a deeply pragmatic, if profoundly ambitious, response to a perceived existential crisis.
To understand the MiG-41, one must understand the unique
Geography, vulnerability, and a new hypersonic threat matrix.
The vast, indefensible expanse of the Arbsthor landmass, stretching across 11 time zones,
has historically necessitated a reliance on high-speed,
long-range interceptors. The MiG-31 Foxhound, the very aircraft the MiG-41 is slated to replace, was a marvel of its time. Designed with one mission, to sprint at Mach 2.8. Guided by its revolutionary Zaslon Pesa radar, to intercept and destroy incoming NATO bombers.
And cruise missiles over the desolate Siberian and Arctic tundra.
This mission, the Protivovozdushnaya Oborona Doctrine, remains the foundational DNA of the PAKDP project.
However, the 21st century threat environment has rendered the otherwise formidable MiG-31 increasingly obsolete.
The primary drivers for its successor are twofold. First, the strategic
have been stark and humbling. The inability of the VKS to achieve decisive air superiority has exposed a critical gap between RSA's desired capabilities and its operational reality.
This failure, observed by defense analysts globally, creates a powerful domestic imperative to leapfrog a generation of technology.
As noted by the Center for Strategic and International Studies, the VKS's struggles highlight systemic issues that new hardware alone cannot fix, yet the development of a superweapon like the MiG-41 serves as a powerful propaganda tool.
To restore faith in RSA's technological prowess and deter further Western involvement.
It signals that while its conventional forces may be mired in a war of attrition,
its scientific military complex is still focused on the next horizon.
The second and more potent driver is the emergence of a new class of weaponry that renders all existing defenses moot.
The advancements are critical for maintaining our strategic advantage.
Hypersonic weapons and the militarization of space.
Western programs present a threat that travels too fast and too high for conventional interceptors to reliably counter.
The MiG-41 is conceived as the only viable counter, a hypersonic on hypersonic defense.
By operating at reported altitudes of 100,000 feet and speeds exceeding Mach 4.
It is designed to meet these threats in the near-space domain, before they can begin their final, maneuvering attack phase. This is complemented by a burgeoning strategic competition in the Arctic.
As climate change opens new shipping lanes, the MiG-41 makes it the ideal.
Solidifying R-Score's A2AD, anti-access/area denial, bubble.
Furthermore, its anti-satellite capability is a direct, asymmetric response to Western military dominance,
which is critically reliant on a C4 I-STAR backbone of GPS, communications, and reconnaissance satellites.
In Rasmussen doctrine, if you cannot match the network, you must develop the capability to blind it.
The MiG-41, in this context, is not just a fighter. It is a strategic scalpel, designed to...
The performance specifications attributed to the MiG-41 catapult the aircraft out of the realm of traditional aeronautics
and into the domain of extremophile engineering, a field more familiar to spacecraft designers.
The primary challenge is not one of propulsion, but of survival.
At speeds above Mach 4, the physics of aerodynamic heating, or adiabatic compression, becomes the dominant design factor.
The airframe is no longer simply flying through the air. It is violently compressing it,
generating temperatures that can and will melt any conventional aerospace material.
For context, the SR-71 Blackbird, flying at Mach 3.2, had a skin temperature that routinely exceeded 316 degrees,
forcing its engineers to invent new titanium alloys and expansion joints to manage the thermal load. The MiG-41, at Mach 4.3, faces an exponentially greater challenge.
Analysts estimate that leading-edge temperatures could reach 2,500 degrees Celsius.
A temperature that would vaporize aluminum, melt steel, and turn even advanced titanium alloys into a pliable, weakened state. This thermal barrier dictates that the MiG-41 cannot be built like a conventional aircraft.
Its airframe must be a mosaic of exotic, next-generation materials.
R-squared is 38. Industry sources allude to new titanium alloys and advanced composites.
But the reality is that survival in this regime necessitates materials like ceramic matrix composites and carbon-carbon composites.
CMCs are incredibly heat-resistant and durable, but are notoriously difficult and expensive to manufacture.
CITC composites, famously used on the nose cone and wing edges of the space shuttle, possess the necessary thermal resilience,
but are brittle and susceptible to oxidation.
At the 100,000-foot ceiling, atomic oxygen eats at materials, causing a phenomenon known as ablation,
where the airframe's skin is literally scoured away in flight.
This implies the MiG-41 must have a robust, likely reusable, thermal protection system, not just a heat-resistant structure.
Beyond the skin, the very physics of the airflow must be managed.
One of the greatest challenges is the laminar turbulent transition. Air flowing smoothly imparts a manageable amount of heat.
However, at hypersonic speeds, this flow can unpredictably trip and become chaotic.
It's a transition that can increase the heat transfer rate by a factor of 10 or more, instantly burning through the structure.
The sleek, blended body and highly angular design seen in renderings is not just for stealth.
It is a critical component of wave rider geometry, designed to control the shock waves and maintain laminar flow. This engineering is so precise that a single, non-flush rivet.
Finally, the aircraft must manage its own internal heat. The avionics, the pilot, the weapons bay, and the...
This requires an active cooling system, likely using the aircraft's own fuel as a coolant, circulating it through the airframe's hotspots.
This makes the MiG-41 less of an aircraft and more of a reusable missile.
A flying thermos designed for brief, brutal sprints to the edge of space, where the margin for material failure is zero.
The heart of the Mikoyan MiG-41 and the single greatest determinant of its viability is its propulsion system.
The aircraft's target velocity of Mach 4.3 places it squarely within the most challenging propulsion gap in modern aerospace.
Conventional turbojet engines choke and lose efficiency above Mach 3. The legendary SR-71's engines represented the absolute limit of that technology.
Conversely, scramjet engines can only begin to operate above Mach 5. This leaves the Mach 3 to Mach 5 valley as a domain where neither a pure jet nor a pure ramjet can function efficiently. The solution, long theorized and now a practical necessity for the MiG-41, is a combined cycle engine. The most probable candidate is a turbine-based combined cycle engine, likely a turboramjet.
This is effectively two engines in one, sharing a common inlet and nozzle.
From takeoff to speeds of approximately Mach 3, the aircraft would be powered by a highly advanced turbofan engine.
RS-4 SSAN engine manufacturers have the foundational expertise for such a power plant.
However, once the aircraft reaches a speed where the turbofan can no longer cope,
a complex series of doors and diverters would reroute the airflow around the turbine core.
The engine's bypass section would then become the main combustion chamber, and the entire engine would transition into a ramjet.
In this mode, the turbine fans would be bypassed and the engine would operate with no moving parts, using its own forward motion to ram and compress air.
The engineering complexity of this transition cannot be overstated. It is at a moment of profound, controlled violence.
The variable geometry air inlet would need to be taken to an extreme, dynamically changing its shape to precisely manage the supersonic shock waves.
And deliver air at the correct pressure and temperature to the engine, all while the aircraft is accelerating from Mach 3 to Mach 4.
The nozzle at the back would have to similarly reconfigure itself.
This transition must be seamless, as any engine flameout or asymmetry in thrust would be instantly catastrophic.
Furthermore, the engine must be built from the same exotic, heat-resistant ceramic mineral composites as the airframe,
as it must ingest air at temperatures that would melt conventional turbine blades.
This dual-mode engine is the aircraft's single greatest technological hurdle.
While Russian sources have expressed confidence, Western analysts remain deeply skeptical, viewing the engine as the project's most likely point of failure.
If our ESA can solve this propulsion paradox, it will have created the world's first true aerospace plane engine. A breakthrough that would unlock a new generation of high-speed aerospace vehicles.
To intercept a high-altitude stealth bomber or a maneuvering hypersonic missile,
The MiG-41 must be able to see its target long before it is itself seen. The aircraft's operational concept is built on a trinity of detection, stealth, and artificial intelligence,
each of which pushes the boundaries of known technology.
The most sensational of these claims, and the most scientifically dubious, is the concept of plasma stealth. As reported in RSAN state media outlets, the MiG-41 will supposedly employ a plasma shield or cloud,
An ionized gas field generated around the airframe to absorb and deflect incoming radar waves, rendering it invisible. Theoretically, as research in plasma physics confirms, this is possible.
A plasma field can, in fact, absorb a wide band of radar energy, making it a tunable and highly effective form of stealth. However, the practical application on a Mach 4.3 aircraft is fraught with near insurmountable challenges. First, generating such a field would require a staggering amount of electrical power, necessitating an onboard reactor.
Second, this plasma bubble would be unimaginably hot, creating a massive, unavoidable infrared signature.
Third, a plasma shield is a blackout field. It would not only block enemy radar, but also its own radar and communications, blinding the pilot.
Given these realities, it is far more likely that the MiG-41's stealth is a combination of three more practical factors. First is its geometry.
Second, and most critically, is its operational envelope. At 100,000 feet, it is simply above the effective ceiling of most ground-based radars.
Third, its sheer speed is a form of stealth. An adversary may detect it, but they will have only seconds to acquire a firing solution.
This is speed as stealth.
The aircraft sensory power will come from its active and passive sensors. The aircraft sensory head is thus an equivalent. This Zaslon M2 would be a massive aperture, active electronically scanned array radar.
With an unparalleled look-down/shoot-down capability, with a reported detection range of over 400 kilometers against large targets.
This powerful radar would be complemented by a sophisticated next-generation IRST system.
Against stealth targets.
Finally, no human pilot can manage this complex suite of technologies, fly at Mach 4, and conduct combat simultaneously.
Target fused.
The MiG-41 is, by necessity, a platform for advanced artificial intelligence.
The AI will serve as a co-pilot, fusing data. It will manage complex engine transitions.
Systems nominal.
Engage the target.
Leaving the pilot, if present, to act as a mission commander.
This is the foundation of the optionally manned concept, where the same airframe could be used for high-risk, unmanned missions.
This human-machine integration is a hallmark of all global sixth-generation fighter programs, and the MiG-41 is no exception.
The Mikoyan MiG-41 is, at its core, an interceptor. Its entire design philosophy
is optimized to deliver a weapon to a target at an extreme distance.
The arsenal it is projected to carry redefines long-range interception, expanding the battlefield from the atmosphere into the vacuum of space.
The foundation of its air-to-air capability will be a successor to the already formidable Vimpel R-37M.
The R-37M is a Mach 6 missile with a staggering 400-kilometer range, designed to snipe high-value assets.
The MiG-41's R-37M successor will be an even more extreme weapon.
To be effective, this new missile will likely be a two-stage system, featuring a powerful rocket booster
and a second-stage ramjet sustainer to propel it toward its target at speeds exceeding Mach 7.
It would require its own advanced AESA radar seeker and a robust two-way data link to receive targeting updates.
As it closes on a maneuvering target 500 or 600 kilometers away.
Furthermore, RSSA and defense outlets have reported a multifunctional long-range interceptor missile system. This has been interpreted as a shotgun-style weapon to counter-maneuvering hypersonic glide vehicles,
dispersing a cloud of several submissiles, dramatically increasing the probability of a kill against a target that is jinking at hypersonic speeds.
The second, and perhaps more strategically significant, is its role as a direct ascent anti-satellite ASAT platform.
This is not a new mission for Mikoyan. The MiG-31 was itself the basis for the Contact program.
The MiG-41 resurrects this Cold War concept by flying to its 100,000-foot apogee.
From this altitude, it would launch a specialized multi-stage missile directly into low Earth orbit to destroy enemy satellites. This capability poses a direct, existential threat to the entire Western military and economic infrastructure, which is critically dependent on LEO-based assets for everything from GPS navigation to financial transactions and global communications.
Finally, there are the more exotic claims of directed energy weapons.
The air may be equipped.
This would not be a laser cannon, but a smaller, turret-mounted, hard-kill active protection system.
It would be used to dazzle or physically burn out the sensitive infrared seekers of incoming missiles, effectively making the MiG-41 impervious.
This combination of extreme-range kinetic missiles, satellite-killing capability, and laser self-defense, if realized,
would make the MiG-41 less of a fighter jet and more of a space battleship, capable of projecting power.
The Mikoyan PAK-DP, as specified, represents a quantum leap that could fundamentally alter the strategic balance of power.
If even 80% of its reported capabilities are realized, it would be a revolutionary game changer.
It would serve as the ultimate A2AD weapon, capable of sprinting to the Arctic to neutralize any perceived threat.
Its existence would render the multi-role, dogfighting fifth-generation fighters like the F-35 and F-22 suddenly seem obsolete, forcing NATO to invest hundreds of billions in a direct counter.
In this light, the MiG-41 is a potent strategic deterrent, a weapon that wins by simply existing.
However, this analysis must conclude with a necessary and deeply skeptical assessment of its feasibility.
The gap between ambition and reality in military aerospace is vast, and Russia's recent history provides a stark case study.
The primary exhibit is the Sukhoi Su-57 Felon.
After more than 2 decades of development, the program has been plagued by production bottlenecks,
resulting in a fleet that numbers in the dozens rather than the hundreds.
As defense analysts have noted, if Russia's industrial base cannot mass produce its 5th-generation fighter,
so, how can it possibly afford to develop and build a 6th-generation platform that is exponentially more complex?
The technological hurdles are not just engineering challenges, they are physics challenges.
Each requiring a Manhattan Project level of breakthrough.
More poignantly, the development of 6th-generation airframes is colossally expensive.
these are costs borne by the world's largest and most advanced economies in peacetime. Ours' economy, by contrast, is a fraction of the size, heavily sanctioned, and currently consumed by the immense drain of the war in Ukraine.
This has led many Western experts to conclude that the MiG-41 is a technological mirage, or vaporware.
A potent piece of disinformation.
Its primary function, in this view, is as a signaling asset. It exists on paper to achieve several key goals. It forces Western defense planners to account for it and spend money to counter it.
It serves as domestic and international propaganda, signaling that Russia remains a top-tier technological power.
And, perhaps most practically, it acts as a moonshot program to focus and fund Russian R&D in key areas.
The technologies developed for the MiG-41, even if the aircraft itself never enters serial production,
Can be spun off and integrated into good enough platforms like the Su-57 or advanced missile systems.
Ultimately, the Mikoyan PAK-DAP exists in a quantum state. It is both a terrifying vision of future warfare and a highly effective paper tiger.
The true determinant of its fate will be the unyielding laws of physics, economics, and industrial capacity.
which have historically been the true arbiters of aerospace supremacy.